Algebra 1. Kyle, Abby, and Micah, welcome to my world. We're going to tackle lessons 75 and 76 on video this morning. The sun has the absolute nerve to shine in my window and create a really weird shadow across my paper because I have a chair on the table. This is how I do it. This is the table. My phone is on a chair hanging over the edge and getting this beautiful down shot on the camera, but the sun is shining, so you're getting a shadow of the chair across the paper. I'm sorry. I'm going to scooch it down just a little so I'm writing in the shadow. Sorry for the technical difficulties. I really need to get that studio built, you guys. But I'm excited for lesson 75 because we're entering into just really one of the hallmarks of algebra. We're going to talk about slope, intercept, graphing of lines. Okay, if I were with you in person, I'd be asking you, what exactly have we talked about? Because I teach so much of this material to so many different classes, I always forget who knows what. So I'm just going to start at the beginning and give you a full review. If you've heard this before, sorry, bear with me. We have something that's called the equation of a line. It always takes this format, y equals mx plus b. This is what we call the equation of a line, and then it has a fancy name. We call it slope intercept format, and I'll explain why. The reason we call it slope intercept format is because these two numbers that we fill in the blanks and put actual numbers in these when we have a specific line we're talking about. But these stand for the slope and the y-intercept, which I'll use shorthand so that my writing doesn't go over there. The slope describes the way that the line goes up. Okay, I'm going to draw two lines. Here's a line that goes up, right? If you were a little car traveling on this line, you would be going up the hill. This is a positive slope. And the sign in front of here would be a plus sign. Actually, there wouldn't be anything at all, would there? Because we don't usually write the plus sign. If the little car that's riding down the arrow is going down the hill, that's a negative slope. And you can see very cute pictures of this on page 307. There's a little, it's a woman in a bun, I think, or maybe it's a dude with a hat on, driving a little convertible up and down the hill. You have to look on page 307 and see the picture, because I want you to always visualize that little person in the car driving up the hill for a positive slope, or coming down the hill for a negative slope. And again, if it was a negative slope, we'd have a minus sign right there. So if you see a minus sign in front of your slope number, don't worry, it's fine. It just means they're going downhill, okay? Now, the slope is written, again, we use m as shorthand for the slope. And if it's a positive slope, we call it the rise over the run. Okay, and again, this is for positive slopes. When we measure the slope, and we'll do this in a minute, you'll see, now this I'm pretty sure we've done. The rise is up and the run is to the right. So when we're counting out the slope from our starting point, we go up for the number of the denominator, and then we go to the right for the number in the, no, I said that wrong, sorry. We go up for the number in the numerator and to the right for the number in the denominator. Sorry, that was confusing. If it's a negative slope, I call it the sink over the run. We go down from our starting point as we count out the slope with a negative, but the run always goes to the right. Okay, so this is how we move from our starting point to the second point so we can draw our line. But where's the starting point, you say? Right here. This, the y-intercept, is the starting point. And this is what I call the treasure map, because it tells us where to go from the starting point to find the second point. And that's a real treasure, right? Okay, so the y-intercept is a simple matter of going to the y-axis and plotting your point wherever it might be. Okay, there's the x-axis. So the y-intercept can be positive or negative. It's easy. You just find that point, and that's where you start from. Then if you have a positive slope, you count up and to the right. And if it's a negative slope, you count down and to the right. Okay, so let's look at the first example, which is on page 306 if you want to look. It says, find the y-intercept. I'm going to squeeze it in over here because I want you to be able to see all this. 75.1. Find the y-intercept of a line whose equation is y equals 3x minus 5. Okay, so John gave this to us. So y-intercept, the first thing we do before we start answering questions is we always check to make sure that this is in the proper format. Y equals a number times x minus, in this case, a plain number. Okay, that's perfect. This is our m, or our slope, and this is our b. See, I'm just matching the formats. So John wants to know what's our, he says find the y-intercept of this line. So the y-intercept equals minus 5. And that's the right answer. Yay! Okay, so far so good. Flipping it over. Example 75.2. John's got a graph for us. Looks like this, and he has a short line that goes like that, and he's got all the numbers on it right here, and it says 0, 5. That's the name of that point. And he says find the y-intercept of the line shown. Well, I'll write it out. The y-intercept is simply the place where the line crosses the y-axis. This is the y. So this is crossing at 5. And if you look at the picture, he's got all the little hash marks on there just to make it sure. So the y-intercept is equal to 5. And that's the right answer. It's just the place where the line crosses the y-intercept. So easy. All right. We're ready to make it harder. 75.3. Find the equations of the lines graphed in the accompanying figures. All right, so I'll do my best to recreate. There's a line that goes like this. This point is 2 on the x-axis. This point is 3 on the y-axis. So we know that our form, he wants us to find the whole equation of this line. We know it has to take this format, y equals mx plus b. We know that this is going to be our slope, and this is going to be our y-intercept. Now, in this example, we don't even have to calculate anything. We're just going to look at the numbers and figure it out from there. So we know that our y-intercept is a good starting place. It's the place where our line crosses the y-axis. That's 3. So I can write b equals 3. Okay, that was pretty easy, right? Now we're going to do the slope. That's the treasure map. The first thing we ask ourselves, is this a positive slope or a negative slope? Is the little lady in the car going up the hill, or is she coming down? Well, she is coming down. So that means we have a negative slope, so we just give it a minus sign. Now we count the sink. It's negative. She's going down the hill. So we're going to measure how many steps down and how many steps to the right we need to go. So 1, 2, 3, 4, 3 down, and then how many to the right? 1, 2. So our slope in this case is negative 3 over 2. 3 down, 2 to the right, to get from one point to the other. And so now we can write the equation of our line is y equals m minus 3 halves x plus 3. Do another one. Example 75 point. This is still 3. There were 2 different graphs. That is cheating, John. You can't put 2 problems into one number and act like you're innocent. There's the graph. You wouldn't have to do this if you were doing the problem in real life. You just look out of the book. The line goes something like this. This number, it crosses here at 4, and it crosses here at -2. My drawing's a little out of scale, but you can figure it out. Okay, y equals mx plus b. That's what we're going for. We start with the y-intercept. This is x, this is y. It crosses at -2, so I know that, b equals -2. All right, is this a positive line or a negative line, the slope? It is positive, so that means I'm looking for the rise over the run. Remember, we use the y-intercept as our starting point and count from there. So it would be 1, 2 steps up, and then 1, 2, 3, 4 steps to the right in order to get from this point to that point. Up 2 over 4, up 2 over 4. We can simplify that to 1/2, can't we? So now, this is m. So now to use this format, we can get the equation of our line as y equals 1/2 x minus 2. Sometimes you'll see this written as y equals over 2. They just mush the x and the 1 together, minus 2. I prefer this one. I like to see my slope as a separate fraction rather than mushing them together. But if you ever do see them mushed, you can just pull them apart like this. So this is the answer that I prefer because of the way the slope is presented. Yeah? What do you think? Now we're going to switch over and do the graphing side of it. We've looked at the graphs and graphs, I don't think that's the plural. We've looked at the graphs, the graphi, and we have figured out what the equation is. Now we're going to get the equation and create the graph. Example, the graphi, 75.4 graph. Y equals -3/5 x plus 2. All right. Crooked graph, just the way I like them. This is x, this is y. We start with the y-intercept. It's +2. 1, 2. There's our starting point. That's our b. This is our m, our y-intercept. Even though we have a creepy fraction here, it's fine because it's just the steps we're going to take moving from this first point to where we'll find our second point. So we go down 3, that's our sink. 1, 2, 3, and then we go over 5. 1, 2, 3, 4, 5. So our second point is right there. Down 3, over 5. We go down because it's a negative. And this point then would be 1, 2, 3, 4, 5. It would be, I did 2 parentheses. 5, -1. We don't necessarily need to know that, but it's good to know. And now we need to draw our line. Oh, that was crooked, but you see the idea. Yay, right? We'll do one more, and then we'll be done with lesson 75. Flippity. Jojo and Joel are starting graphing this week on their own level, and I reminded each of them to get some actual graph paper. I'm just using lined paper right now. I do have graph paper, but make sure that you have some graph paper in the house so that you don't have to make scribbly graphs like I'm doing. If you have the graph paper, it's so much easier. So chime in when your mom and your younger sibling are talking about graph paper and say, oh, I need some too. And actually, I will tell you that Evie Jones found Post-its that were just little pieces of graph paper about like that big. So she could just peel off one of those Post-its and smack it on her regular piece of paper when she needed to draw a graph. Super useful product. So if you can convince your mom to track down some graph paper Post-its, you will be winning at life. So there's that. Not that you're not winning at life already, but you know what I'm saying? You'll be winning even more. Use slope-intercept method. That the whole method. Don't let that phrase scare you. It's what we're doing. Use that method to graph the equation x minus 2y equals 4. I smell trouble. I smell trouble of the worst possible kind. This is not in the right format, this whole equation. We need it to look like this, right? This fails. It's a dead dog. So step number 1 is rearranging everything. So I'm going to subtract x minus 2y equals minus x plus 4, that's a positive 4, and I'm going to divide everything by negative 2. And unlike most of our work in math, I don't care if this is a fraction, that's fine. This cancels, y equals, those two turn positive, and we just talked about what happens when the x out. So I'm going to pull it out. It's x equals, 1/2 x. This, 4 divided by 2 is 2, and we've got one negative sign, so that stays. So here is our graphable version of this starting equation. So now we've got it cute the way we want it. This is the slope, this is the y-intercept. Let's tackle the y-intercept first. This is x, this is y. Minus 2, boom, boom. So there's our starting point at the y-intercept. This is our treasure map. It tells us to go up 1 step because we go over 2. Up 1 over 2, that's our second point. I made it so much smaller. We connect the line between the 2 points and we are happy. That's the right answer. Okay? For your homework in the practice, John gives you some straight lines. So let me just remind you of how those work. If that's our grid, John goes down 3 units and then draws a line here. Okay? This is x, this is y. That looks like 2y. Okay, so this number is -3. That will be helpful. But what does it mean when the line's not tipped? What it means is that no matter what the value of the x is, the x changes, the y always stays at -3. So the equation of this line is simply y equals -3. Weird, right? What about in the other example, we have an x and a y. This one goes to +3, and it goes like that. This is our line. Well, what the heck does that mean? That means that no matter what the y is, x is always -3. I mean +3. Sorry, my bad. So even though that doesn't look like an equation of a line at all, that is the correct answer. When we have horizontal lines, we'll always get y equals a plain number, right? We have to fill it in with the proper number, but it'll always just be plain y. When we have vertical lines, straight up and down, that's when it really goes haywire. Then the equation of that line will just be x equals whatever that value is. So vertical lines are x equals, horizontal lines are y equals. Those are the wild cards that John throws in every once in a while, and you do see them in your practice problems. So be aware of that. Take some notes, dude. You're going to need them. But that's lesson 75. Do a ton of work with lines in the future, so don't worry if it feels a little wonky at first. We'll do more.